Hi, this is about the Spark Python DevOps software engineering course that I am building. This is a course which prepares you more on the Spark side and more on the big data and the infra side on how to handle machine learning projects. Let's see what I have here. So if you can see in the index, I start with a very simple case of multiple and logistic regression and how does the things work in Spark. The other thing that I then go to is Git commands 101, commands like for, clone, merge, which we should be knowing about. Then I go about converting Python code to Spark code, then partitioning in Spark, Pyspark, and different kind of transformation. Mostly it's map, flat map, and those kind of partitions. Then mlib, which allows us to use a Python API, a wrapper, RDD versus data frames, submitting job to Pyspark on the terminal, and then creating wrappers in Python. So the underlying implementation could be in Spark, but we can create Python wrappers using object-oriented programming in Python, and that's where we can talk more about meta classes, closures, the super method, the static method, single underscore, higher order function and decorator, unit testing, and magic method. So those are the Python aspects to do software development to keep everything organized. Then Agile project development is about how to keep it flexible and how to keep everything working in parallel. Then Jenkins 101 and some Linux commands. So this is what I have in my course. I'm going to take you through with the project here what I've been implementing. The first step is to implement a very simple code of linear regression into Pyspark using the mlib library. That's a nice starter. The dataset is available already online and you can pull it into Databricks. So that's like my central point where if you want to use Jupyter based notebook on Spark, that's how you would do that. Then it's about other regression based methods. So this is a subtopic in this, and other quant methods like log likelihood, maximum likelihood, and how does that work. The other area that becomes critical is git commands and the major git commands. So this is like to be done WIP. I'm going to make it as heading 2. How to keep the mix of Python and Spark becomes an interesting question. If you use any SciPy or anything to run regression, it slows down everything because Python does not run on Java virtual machine, so it slows down everything, which is a bad idea. Python is only used as a wrapper, so it's only used as an API. Everything at the back end should work on the Java. There are some links regarding that. Partitioning in Spark becomes a very critical issue. So how many partitions do you have? Whether it's 100, 200, 50. It's also linked to how much memory you have in executive and driver. Is it 5 GB, 40 GB? So then there are some links about how to calculate the memory. Then you have Spark partitioning, how to optimally partition data in Spark. Again, this is a subtopic of this topic, so it should be adding to. Pyspark and transformation. There are different transformation in Pyspark. If you use this transformation, you can do a lot of joins if you have disparate data set. And also a question is, are you using Parquet. If it's structured data, if banks are using structured data, then are you using Parquet? And here in git command, it should be top 10 commands, the work in progress part. Here is to submit a local job on a virtual machine, and that would be one of my headings. This is also heading 2. I'm going to make this as heading 3. Pyspark and transformation. Are you using Parquet? That's my question. Then how does the performance change if you create an RDD versus a Spark data frame? Is Spark data frame also a distributed object? And if it is, how does it differ from RDD? Then when you want to submit something, how would you do that? You have a lot of stuff that comes inside. So how to submit a Spark job, and compilation using Maven. I would say that this would be object oriented and functional part of Python, how to use meta classes and that point, which we deal separately with in the Python course as well. But in the whole ecosystem, the next part becomes Jira and open project development, which is agile development, and it's based up of various sprints under the agile development world. And that's just like a manual on how to use agile development. Then you have Jenkins, which is a part of DevOps, and how does Jenkins goes with in Python. There are some other question and Linux commands. So this is broadly the course that I'm teaching about the entire software engineering part in Python, DevOps, Spark in the quant world. So that's it for now. Let me know if you have any questions.